Good morning, grade 9s. Today we will move on to congruency, a concept that you may be familiar with from grade 8. I'm going to start by first refreshing your memory on the concept and just doing a little intro. Now, what is congruency? So let's look at shapes. So what I have here, I have two shapes. Now, are these shapes the same? They look the same. Are they the same size? So let's look at this. If I place one on top of the other, they map onto each other. So they fit into each other. So these are identical, they have the same shape, and they have the same size. So those are congruent. Let's take this teardrop with that teardrop. What do you see here? The same shape but different sizes. So if I place this one onto that, it doesn't fit onto the other one exactly. So are these two congruent? No, they are not congruent. Let's take another set of shapes. How about this? We have two hexagons of different sizes. They are the same shape, but they don't map onto each other. So they are not congruent. Let's get another shape. How about this? So here we have two hexagons. They look like they are the same size. So let's place them on each other. Do they map onto each other exactly? Yes, they do. So that means they are the same size and the same shape, which makes them congruent. How about this? Here we have two triangles. Can they fit onto each other? Let's see. As it stands, if I slide that onto that, no. But if I move it around and change the direction of the triangle, they do. So, remember, it doesn't matter how the shapes are placed, as long as they are identical in terms of shape and size, they are congruent. So those are congruent. What about this triangle compared to that one? And as you can see, they have the same shape but not the same size, so they are not congruent. Now, let's write down what are the conditions for figures to be congruent. So number one, they have to have the same size. Number two, they have to have the same shape. So irrespective of how they are placed, as long as they have the same size and shape, they are congruent. Okay? Excuse me. Now let's look further. What if I put two lines here? If I say there's a line segment AB, and if I say this line segment is 5 centimeters, then I have another line segment, let's call that CD, which is 5 centimeters. Are they congruent? Yes, because they are exactly the same length and the same shape. What about angles? If I have an angle drawn here of 30 degrees, and if I have something slightly bigger, are those congruent? These are congruent angles. It doesn't matter about the length, but they're congruent angles. Okay. Now, our focus, grade 9s, is on triangles, congruency of triangles. Okay? Now, there are 4 conditions to prove triangles are congruent, and that is what our lessons for the next few days will focus on. Proving triangles congruent, and then we are going to bring up quadrilaterals, which you recently did, and how do we use congruency in quadrilaterals. So I would say I would still need you to go over all your theory. You wrote a quiz yesterday, so hopefully everything is in your mind, fresh in your mind, and you understand all the theory. Now let's start by looking at the 4 cases of congruency. Now I'm going to take you to your textbook. I actually have your textbook here with me, and we're going to look at the page here, which is page 154. Now for this section, I will not rewrite these notes or type them out and upload notes because the textbook has summarized it very nicely. So your page reference for congruency is page 154 and 155 for all the theory. Now what I'm going to do now is focus on the 4 cases of congruency, meaning what are the conditions that can be used to prove triangles are congruent. And there are 4 minimal conditions which we call cases of congruency. The first one, in no particular order, is side, side, side. So for the rest of this lesson, I'm going to go over the 4 conditions, and then I'm going to show you how to identify them. And that's it. In tomorrow's lesson, I will show you how to name triangles, and we will get into identifying the cases of congruency by naming triangles. The lesson following that would involve proving 2 triangles congruent. So I'm going to break down this section into different aspects. It is quite important. Geometry is quite an important concept, and you need to understand how to do this because when you get to grade 12, triangle geometry is a big part of your syllabus. And you need to know how to name triangles, how to prove it, congruent and similar, which will be covered after congruency. Right, so let's start. What does SSS represent? SSS represents side, side, side. So what this is saying is when you have 2 triangles, so let's show you the diagram here. If all their corresponding lengths are equal, they are congruent. Congruent means they are identical. So 3 pairs, what is given or can be deduced with this case of congruency? So remember, SSS represents side, side, side. You're looking at 3 sides. AB is equal to DE. BC is equal to EF. And AC is equal to DF. So there are 3 sides that are equal to each other, which therefore proves that triangle ABC is congruent to triangle DEF. And for those of you who don't know, 3 horizontal lines represents congruent triangles. Okay. Now, as I said, in the next lesson, we'll focus on how we name the triangles. Today's lesson is just focusing on identifying the 4 conditions to prove congruency or the 4 cases of congruency. Now, by proving that the triangles are congruent, what does congruency actually prove? Remember, congruency means identical. So if the sides, the corresponding sides are equal, it would imply that the corresponding angles have to be equal if the triangles are congruent. Okay, and that is what is stated here. What else can now be assumed? So because the triangles are congruent, we can now say that the angles are equal. The corresponding angles are equal. So the first case of congruency is side, side, side. Case number 2. Here, A represents angles and S represents side. So you are looking for 2 angles, 2 corresponding angles that are equal and 1 corresponding side. So remember, you are comparing 2 different triangles and you have to look for what's equal in one triangle that corresponds with something that's equal in the second one. So how would we represent that? So let's draw a little diagram for you to show you what that means. Okay, so let's look at this one. Side, angle, angle. So you are looking for 2 triangles where the angles are equal. You have 2 angles and a corresponding side. And actually there's a nice question here in your textbook. So if you look at this example here. So you've got triangle ABC and you've got triangle DEF. Angle A is 34, angle D is 34. Angle B is 85, angle E is 85. AC is 52 and DF is 52. So you've got two angles and one side, which meets the side angle, or you could write it out as AAS. Doesn't matter. So when you have two pairs of corresponding angles and one pair of corresponding sides equal, you can conclude or prove that the two triangles will be congruent. Now, let's look back at this question here. Because we are now saying that these two triangles are congruent, what does that now mean? It means that the remaining angles and sides will be equal to each other because the triangles are proved to be congruent, meaning they are identical. So if I take triangle ABC and place it on top of triangle DEF, it will map onto each other, fit exactly. So that means that angle C will therefore equal to angle F. Side AB will be equal to DE and BC is equal to EF. Okay, so that's the second condition of congruency. As I said, it's no particular order, it's just the way it's stated. Now this one, where there are two sides and an angle. Now this is an important one and a confusing one. And with this one, it has to be written as SAS because that A means something quite important. And if you look in the textbook, there's a word here, included. What does included mean? Now, I just want to take you to a diagram and I want to show you something quickly. So if I have triangle A, B, C, and if I have another triangle next to it, so let's draw it here. Let's draw triangle CDE. And if it was given that that angle is equal to that, that side is equal to that side, excuse me, that angle is equal to that angle, and this side is equal to that side. So let's look at what we have here. Will these two triangles be congruent? So I have a side, so I have S. I have another side, so I have S, and I have A. But what's missing here? So these two triangles are not congruent because of this angle. This angle is not included. Remember, SAS means side included angle side. What does included mean? Included means that the angle must be the angle formed between the two sides that you mentioned. So if we are mentioning CD and AB, it means if you bring CD and DE together, we should have this angle that's equal to this angle, and it was not given. So the included angle, the angle between the two sides mentioned here, must be equal in order to use this condition. So in this particular example, the triangles are not congruent because this angle is not included. Okay, I hope that makes sense. So look out for that one. That's quite an important one, and learners confuse that one. So it doesn't mean because you have two sides and an angle, they are automatically congruent. No, it has to be an included angle. So in the textbook, it highlights two pairs of corresponding sides and the pair of corresponding included angles are equal. And I've just explained that to you. As I said, please, the summary of the four cases are here on page 154 and 155. Very nicely put down. So you need to constantly refer to that if you have forgotten your theory. And then the last condition is called RHS. It means right angle hypotenuse side, or 90 degrees. You could write it 90 degrees hypotenuse side. As we know, a right angle is 90 degrees. So what are you looking for here? You are looking for obviously the right angle in each triangle. You are looking to see if the hypotenuse sides are equal, and then you can look for any other corresponding side that is equal. Okay? And if you have these three criteria, then means you could use this case of congruency to prove that the triangles are congruent. So if you look at the diagram here, and let's say we say those two are equal and those two are equal. So in triangle ABC, you have angle A equals to angle D. You've got the right angles. you have the hypotenuse sides that are equal. Remember, hypotenuse side is the side that is opposite to the right angle. And if the hypotenuse sides are indicated as being equal, then this would apply. And then you're looking for any other side. It doesn't have to be included or whatever. It just has to be any side that's corresponding. So you've got AB is equal to DE, hence 90 degrees hypotenuse side. Okay, grade 9. So those are the 4 conditions for congruency. And on page 155, at the bottom of page 155, as shown here, go over this. It's exactly what I've explained, but here they have numerical values, so it makes a little bit more sense when you see numbers. And there's the 4th one is at the top of page 156. So on your work schedule, I would put the page references down for you so you know which page to look at for the notes. You don't have to rewrite them, it's in your textbook, so you can do that. Now, what I have planned for you for the rest of the lesson, as I said, this is a very short lesson, just theory, a lot of theory, so you need to go over your theory. So you will find a worksheet that looks like this. I've cut it up. It's an A4 worksheet. On the left hand side would be page 1 and on the right hand side is page 2. So your task for today, after watching the video and after reading the notes on page 154 and 155 again, you need to do this worksheet. I'm going to do A and B with you just to show you how to go about doing it, and then you will answer the questions in your workbook, your maths workbook, and you will write it down as, please, today's date, congruency, worksheet on congruency, page 2. Always provide a heading so you know where your work is if you need to go back. And all I want you to do for this exercise is state which condition for congruency makes the following pairs of triangles congruent. So when you see this word condition for congruency, immediately you need to think about the 4 cases of congruency. Okay? So the 4 cases are, in abbreviated form, side, side, side. Side included angle side. Angle, angle side. Or if you want to write it as SAA, doesn't matter. Or ASA, it also doesn't matter. And right angle hypotenuse side. The only one that the order matters is that one, the side angle side one. So all you do is in your book you write, or you could actually do it on the worksheet. If you don't have access to a printer though, where you can print out the worksheet, you have to write it out in your book. So let's look at A. So let's see, do we have, so obviously these triangles are congruent to each other, because we are asking what is the condition that's making them congruent. So we don't have to prove they are congruent. It is given that they are congruent. Why are they congruent? So let's look at it. You have that is equal to that. So that's one side. So my advice is, as soon as you find something, write it down in terms of S, A, and S. You have a second, the double arrow is showing you that those 2 sides are equal. So there you have another side. There are no angles that are indicated as being equal, but you have something here, which many learners overlook. This middle line is a common line, and it joins both triangles together. So it's the same line, and it's a common line. Obviously, it would be the same length for both triangles. So we consider the common line as an equal line. So that will be the 3rd side. Okay? So you would write out question 1A in your book and you would say SSS, or you could say side, side, side. If you have the worksheet printed, then you can just do it the way I'm doing it on this worksheet, where you write it down next to it. Okay, let's look at B. I will do one more for you and then you have 4 questions to do for the rest of this lesson. If you look at B, now they've given you an angle. So this little section here is equal to that section here. So we have an angle. So let's write down what we have given to us. Always write down what's given. An angle. We've got a corresponding angle that's equal. And then this little line here is showing you that you have a side. Okay, so now we've got one angle and one side. We either need another side, but remember, if we get another side, that angle must be included, or we need to look for another angle. Now it's obvious that we don't have the other angle, so we've got to look for a side. Now remember, that side is given, that angle is given, and in order for that angle to be included, we've got to look at this side. which is the common side. And yes, it would work. So that side would be there. Because there's your side, there's your included angle, and there's your other side. So the angle that you mentioned lies between the two sides that you mentioned. So side, angle, side applies to this diagram. Okay, grade 9s, I hope this makes sense. Again, if you don't understand, very few learners email and ask me for help. Very few learners join the live interaction lessons when I had it in the first 2 weeks. I didn't have it in the third week because of that reason, but I did say on the stream that if you need me to come on for that lesson, you need to send me a message via email or post a message on the stream and I will immediately come on. I am available. But sometimes I find that learners just come in there, say hello, and they leave, and it's not used the way it should be used. Okay? So please make use of the opportunities given. Make use of us. Make use of the ASPs on a Wednesday if you don't understand. But ask questions. That's why I'm your grade 9 teacher, your online teacher. I'm happy. I will happily answer your questions for you. And if I have to book a session with you privately, I will. So please, grade 9s, please don't sit back and just take the information in without understanding. Ask if you don't understand. Okay, have a good day. We'll see you tomorrow. Bye-bye.